If we have a class with a mean IQ of 110 and a standard deviation of 10, how do we model that on a normal curve? Well, the first thing we have to do is sketch a normal curve. Now I'm going to sketch it small here and explain, then we'll point to the diagram that I used in class. So to sketch a normal curve, we put -2 here, -1, 0, 1, 2, and these are our z values. And we sketch a middle, and we probably sketch an axis of symmetry up to the point where our distribution is going to peak. Then we come down halfway and up a little bit to get our 60% level. And we come down half, cut that in half, cut that in half again, and we've got a line where we're at about 1/8 of the middle height. Where z equals 1, we come up to 60% height. Where z is -1, we also come up to the 60% height. At z equals 2, and my z equals 2 is too close to z equals 1 there. These intervals need to be equal. These numbers need to be equally spaced along the z-axis as best you can do it. I didn't do it perfectly, but you can do better than this. Okay, then at -2 and 2, you're going to get to 1/8 height, and you're going to sketch a line that's asymptotic to the negative x-axis, comes up to the peak, comes down here, and comes out asymptotic to the x-axis again. That's the picture you get. Okay, now, if this represents a class with a mean of 110 and standard deviation of 10, if that class is normally distributed, if the IQs in that class are normally distributed, and they probably wouldn't be, but let's assume that they would. Let's not worry, at least right now, about why they might not be. 110 is our mean, and our mean is at z equals 0. Our standard deviation is 10, so every time we move one standard deviation, remember our z values represent one standard deviation every time z changes by 1. So from here to here is one standard deviation. From here to here is another. Okay, well, if the mean is at z equals 0 and it's 110, then if we go to z equals 1, we have to move over one standard deviation. The standard deviation is 10, so we move to 120. Another standard deviation takes us to 130. Standard deviation over this way takes us down to 100, and over here to 90. That's how we construct the normal curve, and you should be able to construct it at least as quickly as I did, because you won't have to be explaining it. Well, okay, here I've constructed a bigger one. And I've written down that the mean is represented by x bar, which is 110. We've seen this notation. And z equals 1 corresponds to mean plus standard deviation x bar plus sigma. So our x values will be just what I wrote up there. 110 here, 120 here, 130 here, 100 here, and 90 here. Now I'd label them a little more consistently. I'd have a line for the x values and a line for the z values, kind of like we did here. But I've written all this stuff below, so it wasn't practical to do that. But everybody did that, so I think you understand how you might want to make this look to make it easy. Okay. Now I asked you to sketch the region under the curve corresponding to x values between 115 and 125 and estimate the area. Okay. Well, if you haven't done this, you probably ought to give it a shot, but everybody in class did a good job with this. Okay, everybody figured out that 115 was here, 125 is here. 115 halfway between the mean, which is 110, and mean plus one standard deviation, 120. Halfway between z equals 0 and 1, we have the 115. And the 125 is halfway between 120 and 130. That's halfway between z equals 1 and z equals 2. So here's the region. And people estimated the area under this region. I estimated from my picture, it looks like about, I thought it was about 28%, but my picture isn't real good because my 60% is a little bit too high. Okay, the curve should come down a little faster than it does. So, you know, I didn't do a great job of drawing the curve, and I didn't get a great estimate, but, you know, got something to compare with what we get if we look at the Z table in your text. Okay, at this point I said, okay, figure out what's Z here and what's the value of Z here. Well, you know what, everybody got that. Everybody said, okay, well, that's between 0 and 1 and it's halfway, so 115 is Z equals 0.5. 125 is halfway between 120 and 130. That's halfway between Z equals 1 and Z equals 2. That means this is at Z equals 1.5. So on the Z scale here, we're at 0.5. Here we're at 1.5. And people did a really good job with that. Okay? Now, I then asked you to look at the Z table. Okay? Z equals 0.5 in the table corresponds to area 0.19. Z equals 1.5 corresponds to area 0.43. But what area is this? Neither one of these is this area. Okay, well, there's a little picture on the same page as your book, and it looks like this. So, you know, ask everybody to draw that picture because you want to remind yourself what the area is. And the area that you get when you look up 0.5 or 1.5 or look up any value of Z is the area from the middle of the curve to that value of Z. So I didn't finish this on the board because everybody got it, but I should finish it here, of course, since you might want to look at this. Okay, so the 0.19 is the area here. This is area 0.19, 19% of the total area. And that lies between the middle, Z equals 0 if you wish, and Z equals 0.5. Okay, so that's this area. That's the area from here to here. Area of this region. Now what's the 43%? Well, the 0.43. The 0.43 corresponds to Z equals 1.5, so that's the area between the middle and 1.5. So from the middle out to 1.5, that area is 0.43 of the total area. So I kind of put, that's the area that goes from here to here. This is the area that goes from here to here. Well, if you want to find the area from here to here, and you know the area from here to here, and you know the area from here to here, it should be fairly obvious that you should subtract this area from this area. So the area from 1.5, or from 0.5 to 1.5 is 0.43 minus 0.19. So the area is about 0.24 or 24% of the total. Now, a lot of people did estimate this as about 25%. Based on my picture, I said it would be a little higher, but I did say that my picture's a little high, so maybe it wouldn't, and it wasn't. It was actually a little lower than I thought it might be. Of course, I knew these numbers, but I didn't use them, okay? I just ignored what I knew about the numbers, and I just did a visual estimate, and that's all I ask you to do. You do a visual estimate, you draw the region, then you use the information given you by the Z table, and you put it together to figure out the area of the region you want. So, area of this red hatched region is 0.24. 0.24 of the total. Very important that you understand how that works.